Alright, now we are in the word example. Now let's take a look here. Currently we have sulfur dioxide gas reacting oxygen to give you sulfur trioxide. This is an exothermic process. Now let's take a look what do they say. They say that when a 2:1 ratio of your sulfur dioxide and oxygen at a total pressure of 3 atm is passed over a catalyst at 450 degrees Celsius, the percentage conversion of SO2 into SO3 was found to be 98%. So we need to calculate the equilibrium partial pressure of SO2 and O2 and hence find the Kp value. Now with this in mind, let's take a look how we actually find the Kp pressure expression first. So write down the Kp expression based on the balance equation. So this is the balance equation. Let's go ahead and write down the Kp expression. So your Kp expression is actually equals to partial pressure of your SO3 to the power of 2 divided by the partial pressure of your SO2 to the power of 2 multiplied by the partial pressure of your O2. Now this one is actually right to the power of 1, so I just leave it as it is. This will be your expression of your Kp. Now moving forward, we will take a look at how we actually solve the ICE table here. Now you realize that the ICE table I written down here is all in atmospheric pressure, ATM. So let's trace back a little bit here. What is ATM? Now you realize that in this question they say 2:1 of SO2 and O2 at total pressure of 3 atm. So meaning that your SO2 must be 2 atm. Your O2 must be 1 atm. So with this in mind, let us go ahead and write down the expression. We know that this one must be 2 and this one must be 1. Then after that, they say one more thing. That is the percentage of conversion of SO2 into SO3 is 98%. So what I'm doing is I go and calculate, 98%. This one must be 2 multiplied by 98 over 100. So when you do your calculation, you should realize that the value should be approximately 1.96. So therefore, this is actually the product amount. Then initially this one must be 0, this one must be plus 1.96. But do they know what? This is 2 ratio. So if your product increases, therefore your reactant must decrease. So this will be minus away 1.96 divided by 2. Then this one must be minus 1.96. Now why this one is minus 1.96 divided by 2? Because this is 2:1 ratio. This is 2:2 ratio, so minus accordingly the same amount. And after that you'll be getting a minus 0.04. Because you left with this amount. Then after that, when you do the subtraction, you should be getting as 0.02. So you can see that this is the leftover amount. So with this in mind, let's go ahead to calculate the Kp pressure. But first of all, we will rewrite the Kp expression again, which is actually your partial pressure of your SO3 squared divided by the partial pressure of your SO2 squared times partial pressure of your O2. Now I just simply sub in the value. Your product is 1.96 squared divided by 0.04 squared times 0.02. You should be getting the value of 120050. Now if you approximate it, that will be approximately equals to 120 kilo. So the next thing is, how do we actually find out the units? So to find the units here is very simple. What you need to do is that you write down here, this is actually ATM squared divided by ATM squared times ATM, because ATM is the units of the pressure. You realize these two cancel out and you bring this up to the numerator, you will get ATM power minus 1. Therefore, the units here should be ATM minus 1. That is the answer. Okay, so with this in mind, do go ahead and try the checkpoint on the next page. Make sure you try it before you check your solution.